Hello there, Mr. Sutton here with the AB Calculus 3-1 classwork extra practice solutions on the power rule. To take the derivative of this function, we're going to first rewrite it with non-fractional x values here. So I'm going to rewrite this 8 over x to the 8th as 8x to the negative 8. And now I can just use the power rule straight across. So going from left to right, I've got 5 over 2 times x to the, 1/2 minus 1 is going to be negative 1/2. For this next one, I'm going to have negative 64 times x to the negative 8 minus 1, so negative 9. To take the derivative of this function, I'm going to rewrite this with only exponents, no radicals. So this first term I'll write as 8x to the 5 over 6. And this next one is going to be negative 10x to the 5 over 8. Using my power rule, I've got 5 times 8 over 6, so that's going to be 40 over 6, or 20/3. And then we'll have x to the 5 over 6 minus 6 over 6, so that's negative 1 over 6. Next, this is going to be, 10 times 5 over 8, that's 50 over 8, which I can reduce to 25 over 4, so negative 25 over 4. X to the 5/8 minus 8 over 8 is going to be negative 3/8. To find the derivative on this one, I'm going to rewrite this with exponents rather than radicals. So this first term I'll write as 3x to the 1/2. For this next one, I've got minus x to the, this is going to be the 1 over 3 power, but we're in the denominator, so that's negative 1/3. And now let me just use my power rule. So I'm going to have 3 over 2. X to the 1/2 minus 1 is going to be negative 1/2. For this next one, I've got, positive 1/3 times x to the negative 1/3 minus 1. That's going to be negative 4/3 down there. To find the derivative of this one, I'm just going to go straight across and use the power rule. So this first one is a little bit tricky because we have this b in the exponent. B is a constant, so I just treat it like a regular constant, and it gets multiplied with the 3 by the coefficient here. So I end up with 4 times 3b, or 12b. Then we've got x to the 3b minus 1. Now, since I can't really combine any like terms here, I'm just going to have to leave the exponent that way. Moving on to the next one, this is going to be negative 9 times x to the negative 9 minus 1. So that would be x to the negative 10. For this problem, I'm trying to find the limit as h approaches 0 of all this craziness. Now, the key on this one is realizing that I have the limit form of a derivative. So if I can figure out what I'm trying to take the derivative of, take the derivative just using the power rule, and then plug in whatever they want me to, this will be a much quicker problem. So to figure out what I'm taking the derivative of, I just look for the something plus h expression. In this case, that's x plus h. What's happening to x plus h? Well, I'm cube rooting it, so this is really just the cube root of x if we write this as a regular function, plus 6 times x. And now if I want to take the derivative of this, let me just rewrite this first term as x to the 1/3. And now f prime, I'm going to have 1/3 times x to the, this will be negative 2/3 if I subtract 3/3 from 1/3. And then 6x derivative of that is just going to be 6, just using our line rule there. So what am I plugging into this? Well, I look back up here and I see that I have x plus h rather than some number plus h. Since it's x plus h, that means I can just leave this as x and be done. To find the limit on this problem as h approaches 0, we need to recognize that this is actually the limit form of a derivative. So if we just write the original function and take its derivative at some x value, then that'll actually give us all this craziness here. So what is the original function that we're trying to find the derivative of by doing this limit stuff? Well, if you look at the something plus h expression and what's happening to that, and just replace that with x, you'll figure this out. So we have 1 over 2 times 4 plus h. This is really the function 1 over 2 times x. And if I want to take the derivative of that, I'm going to rewrite this as 1/2 x to the negative 1. Using my power rule now, this is negative 1/2. X to the negative 1 minus 1 is negative 2. And now I have to go back to the original problem and see if there's something I was supposed to plug in for x. Well, I see that I have a 4 plus h right here. So that means I'm supposed to plug in 4 to the derivative. So I'll rewrite this as negative 1 over 2 times 4 squared. This is really then negative 1 over, let's see, 32. On this problem, I'm given this f of x function, and I want to find f prime of 2. That means I need the derivative of f, and then I just plug 2 into that. So to find the derivative, this will be a little easier if I rewrite 4 over x as 4x to the negative 1, because then I can go ahead and use the power rule on this first term. So going left to right and doing that, I've got negative 4 times x to the negative 1 minus 1 is negative 2. Next, 5x just becomes 5, the slope of a line 5x. Negative 1 is a constant, so the derivative of that's just going to be 0. So now all I have to do is plug 2 into all this stuff. So I can rewrite this as negative 4 over 2 squared plus 5. Well, this is really negative 4 over 4, which is negative 1. Negative 1 plus 5 comes out to positive 4, so that's choice A. For this problem, I'm given x to the 3 halves as my f function, and I want f prime of 4. So I just need to take the derivative of this thing and then plug 4 into it. So the derivative of this, just using my power rule, that's going to be 3 halves x to the 3 halves minus 1, so that's 1 half. So if I plug 4 into this, this is really just 3 halves times the square root of 4. 3 halves times 2 is just going to be 3, so choice C. For this problem, we're given y, and we want dy over dx, the derivative of y with respect to x. I'm going to start this problem by rewriting with exponents that aren't in the denominator here. So I've got 1 half x to the 4/5 minus 3x to the negative 5th. Now I can just use the power rule. Going left to right, I've got 4/5 times 1 half. That's going to be 4 over 10, or 2/5. And that's going to be times x to the 4/5 minus 5/5, so negative 1/5. For this next one, I've got negative 5 times negative 3 is 15. And then that'll be x to the negative 5 minus 1, so negative 6. Does that match any of my answer choices? Not quite. It looks like they don't have any negative exponents in their answer choices. So let me just convert these to positive exponents. For this first one, I've got 2 over 5x to the positive 1/5. And this will be 15 over x to the positive 6. So that's going to give me, let's see, answer choice. Looks like choice A. On this problem, we're given this polynomial, and we want f prime of 2. So we just have to take the derivative of this thing and plug 2 into it. Using my power rule, going left to right, I've got 3x squared minus 2x plus derivative of x is just 1. Derivative of negative 1 is 0, so we don't have to write it. All I have to do now is plug in 2 for all this. So this is 3 times 4, which is 12, minus 4 is going to be 8, plus 1 is 9, giving me answer choice B. On this problem, they're asking me for the derivative of all this stuff at x equals negative 1. To make my life a little bit easier, I'm going to rewrite this with negative exponents. So this is really x to the negative 3rd minus x to the negative 1, and x squared is still playing itself in this motion picture. Let me next take the derivative using the power rule. From left to right, we have negative 3 x to the, let's see, negative 3 minus 1 is negative 4. Next, this is going to be positive x to the negative 2 plus 2x. Let me plug negative 1 into all of this now. So going left to right, this is just going to be negative 3 times, well, this is just positive 1 here, so negative 3 overall. This next one, negative 1 to the negative 2, well, that's really 1 over negative 1 squared, that's just 1. This will be negative 2 over here. Negative 3 plus 1 is negative 2, minus another 2 is going to give us negative 4, so that's choice B.